Hi, James.
Hey, good morning over here. Sorry, it's evening over there.
Yes, James, it's good morning for you and good evening for us. And I hope this is the last session for the Indian audience.
Cool.
So, how are you today?
I got my coffee. I'm halfway through my first cup, so I'm doing good.
Okay, good, good. So, thanks for joining us, James. Let me give a quick intro for the audience, and the stage is all yours.
Okay.
And hi everyone. James is going to discuss about data lakehouse and the data mesh and data fabric, everything related to the data today with us. And he wants to share his experience and uh, I'm sure that it will be more interesting, though it is a last session. But again, and James works for EY and who's our sponsor, one of the major sponsor for this event, and as a data platform architecture lead. And before that, he worked for Microsoft for 7 years as a solution architect. Regarding, he worked in various data warehousing projects, and his specialities are the business intelligence, data warehouse, big data, Hadoop, cloud, master data management especially. It's very interesting for me. We do a lot of MDMs nowadays, and the machine learning solution architecture, etc. So, uh, thanks, James. Once again, thanks for joining us, and the stage is all yours.
All right, awesome. Let me share my screen.
Yep,
Hopefully this comes up okay. All right,
yep.
good.
I hope everyone should be able to see that now.
Yeah, cool. So welcome everyone to the last session of the day. Last but not least. Oh, maybe it's least. We'll see. We'll see what the feedback is. As mentioned, thanks for the introduction. I'm a data platform architect lead at EY. One of the sponsors. I also worked for Microsoft for 7 years before that, the other sponsor. And we already went through the about me, but I'll just point out a lot of the things I talk about in the presentation today, I further expand on in my blog at jamesserra.com. So you want to check that out if you want more information. What we'll go through today in the next hour is we'll talk about what is a data warehouse, what is a data lake, what's the modern data warehouse, and then dive into what is a data fabric, what is a data lake house, and what is a data mesh. A lot of these buzzwords are out there, and I know there's a lot of confusion and what's the difference between these all. This is my opinion of what these all are. It's certainly not this industry consensus of there's a lot of this differences in what these can mean, and I'll try to point those out along the way. So when I think of trying to figure out all these buzzwords on my own, I feel like I'm passed out drunk in the Denny's in the parking lot. So I'm going to try to prevent that happening today by trying to clarify what all these terms are mean. And somebody had once asked when I've been presenting this slide for a while, and if that's me, and no, it is not me. I was never passed out drunk at a Denny's. So what is a data warehouse and why use one? So this is what I like to do to kind of level set of where somebody may ask, well, what's the whole point of a data warehouse? Why do we need one? Why can't we just continue doing things the way we have? And I point out there's a lot of reasons on there. Some of the bigger ones is reduce stress in the production system. If you have queries hitting that OLTP application on there, your chances are you're going to get a lot of complaints because those queries can take a long time and saturate the compute of that source system. You can optimize them for read, so the queries can be and reports can be a lot faster. You can integrate many sources of data, so it could be all sorts of ERP and CRM systems and homegrown apps are all put in that data warehouse. You can keep historical records, so you can do it so you don't have to create hard copy reports for every month, and instead you put it all into a data warehouse. You can have things like uh, slowly changing dimensions to keep track of how things have changed over time. So it's allows you to go back in history at any time without having to go and save things out like you do in an OLTP system usually. You can make things more easy to understand. If you look at some of the ERP systems, especially, they could use field names and table names like T116. Well, when you create a data warehouse and you move all that data into it, you can rename those fields to something meaningful. The point being, you're going to get self-service. You want self-service BI so people can end users can create their own reports without having to get IT involved. And one way to do that is to make the names a lot more understandable. It also protects if they upgrade the source system of the OLTP application in there. You're not breaking things if you don't use a data warehouse. So with a data warehouse, it kind of shields you from updates to the source system. You can add things like MDM, master data management. You can put hierarchies in a data warehouse, things that you couldn't put in the source systems. And to get that end user involvement, the BI on demand by an end user in there, if you set it up a data warehouse correctly, especially with the tools today like Power BI, it could be very easy for end users to create their own reports. And then you can improve the data quality because you'll find problems that with the data that need to be cleaned up as it's built in a data warehouse, and you can go back to the source system and say, hey, we've been getting this field of birth dates, and some of these birth dates are before, after today's date, or their people are 200 years old, and you need to go and fix those. So those things come out when you build a data warehouse. And you get one version of the truth on there. So if anybody has any questions about some of these reports or queries, it's very easy to go to the source system. It's one version of the truth because all the data is collected in one area, and that's your single source of the truth. And then it's very easy to build BI solutions on top of that, like analysis surface cubes or Power BI now. Anything that any reporting tool you want to use can just go to the data warehouse. They don't have to go and recreate all the connections to the source systems in there. So that's what a big benefit you get for data warehouse. And this was another one that's you find many people don't think through is if you have reports going against all the source systems, you have to give somebody access to all those source systems, and that could be a big pain. And they cannot be able to get security for some of those systems. So if you copy everything into a source system in a data warehouse, and you just got to give those people access to that one location, not all those source systems. And then finally, the whole point of a data warehouse is to make better business decisions by getting greater insights into your company. So this is the main focus of a data warehouse. And you're making that process a lot easier by collecting all the data in one location. Now, for those of you who are architects like I am, this is what you may think of as we need to go and build a data warehouse, and we have a bunch of tools. And we need to decide which of those tools we're going to use to build our data warehouse on there. So there's a lot to choose from. However, and I'm going to go over in this presentation, talk about some of these tools. However, there's a lot of tools are available that I'm not going to talk about. Here's a list of those. And you can see it. I could spend probably weeks going over all these different tools and options on there. So we're confined to the Microsoft world, and we're confined to certain products in the Microsoft world in this discussion. There's also a lot of concepts not covered on this deck on here. I don't get into things like comparing virtualization and going into high-availability disaster recovery. So there's a long list of stuff on here. So what makes our job as architects so tough is all these concepts and products out there. So our job is really more like this. We have so much to choose from. And when I'm with customers and trying to figure out what they need, there's a lot of questions I will ask to try to narrow down this large set of tools. And these are some of the questions I will ask. For example, what are your current skill sets on there? So I'm not going to go recommend Spark if nobody in the company knows what Spark even is. I'm going to ask what are your licensing requirements, because that could affect what products I recommend for you. Is it streaming the data? All these things come into play. So it's really important when to do discovery, when you're looking at building a data warehouse, and ask all these questions. And we'll make this deck available so you can use it as a takeaway on there. But this is where I see a lot of problems with new data warehouse projects. And a big reason why they fail is there was not enough time put in to ask a lot of these questions. So make sure you carve out that time. What is a data lake? this fortunately don't have to explain to customers for the most part nowadays. And I deal mostly with the larger customers, but there's plenty of smaller companies that may not know anything about a data lake. And so you want to point out why a data lake is in almost every case is going to be part of building out a data warehouse solution, no matter what concepts we're talking about. And the things I like to point out, especially if it's a company that has built a data warehouse or relational database solution, they may go, well, what's the point of a data lake? And the first thing I point out is think of a data lake at the very least as a staging area for your data. Instead of putting a staging area inside of your relational database, and you have the issue when you do that, you have to have a maintenance window, kick everybody off, you load data in there, and then you clean it, and then you make it available for end users. And so what happens if that maintenance window, you start bumping up against it, and you're just importing so much data and cleaning it, and you're running into issues where there's a problem, and now you have to keep people off of the relational database data warehouse until you fix it. So what you can do with a data lake is you copy all the data into a data lake, which is a schema on read, which is just a glorified file folder. I can copy data in there. I don't do anything up front. And then I can, within this data lake, which is just storage, I can put compute on top of that and clean it all in this data lake. And when it's all finished, I can then copy it into the relational database. And so instead of having this large maintenance window, I may only have a few minutes where I'm copying that. All that cleaning is done in the data lake. So moving that staging in there is a big one there. Plus, you can use as much compute as you want. If you want to pay more for extra compute to get the data cleaned faster because you're getting more and more data in there, you can do that. You're not limited on the compute in the relational database. You can also use it to explore data. I was a DBA for many years, and I had clients come to me and users say, hey, this data, I think we can use it. Can you put it into the data warehouse? So I would go into that relational database, I create a table and the fields and the schemas and write the ETL and copy it in there and do all this work and then say, okay, it's ready. And they would look at it and come back and say, oh, actually, we don't need this data. It turns out it's not valuable. And you say, well, I wasted all this time. With the data lake, because it's schema on read, I can just copy it into a folder. And you can have an end user, especially with the tools nowadays, who can just query that and see if it has value. And maybe they just need a one-time report and you're done. Maybe they see it needs value and you can then copy it to a relational database. But you're avoiding all that wasted effort for something that turns out to be not important. So those are just a few of the things on here. So a lot of reasons to use a data lake. And we'll talk more through about some cases where you want to use just a data lake. And there's a very rare case when you wouldn't want to use a data lake anymore unless it's a very limited amount of data. But you also have to think about your future. Too often I've seen customers say, well, we can skip the data lake because we don't have that much data. And that's true today, but a few months from now, they get more and more requests. And they find out, well, we should have had a data lake because now that small data warehouse has grown tremendously. And it always happens. A data warehouse never ends. It's always growing. And people start using the data and they see the value in it and want more and more data on there. So always expect that your data warehouse is going to grow by leaps and bounds with requests to put more data inside of it. So if we have both a data lake and a data warehouse, what are the differences at a high level? And this is where I have this slide. So you can think of the data lake as the staging area and the prepping areas I talked about. And then the data warehouse will become your serving layer in security and compliance. And the reason why you have both is there's certain trade-offs that happen if you don't have a data warehouse, this relational solution, and just have a data lake. And we'll talk through some of those, but right away is you think of the security. In a data lake, it's a file and folder base, so there's no row of security or field level security in there. So you may want to have a data warehouse for that reason. It also could be for performance. A data lake can get you very fast queries, and it could be seconds, but that could be too slow if you're creating a dashboard and you need to slice and dice the data. And so you want to put it in a data warehouse for millisecond response. And sometimes it's just people are more used to the data warehouse and relational format in there. So this is those top points I can think of why you want to have both. And we're starting to see a little bit of situations where you can go with a data lake and not with a data warehouse, and I'll talk more about those. But I would say in 99% of the cases, you're going to want to have both a data lake and a data warehouse and understand the difference between the two and the purposes of the two. The data maturity stages, this is what I like to cover with customers to see where they are in the journey. And most of them are in stage 2, in that stage 1, you have data all over the place. Stage 2, you're starting to collect and centralize this data. And this allows you to go and look at the rearview mirror and look for patterns, look for reasonings why, for example, my bicycle sales are not good in certain states. I need to collect all this data and centralize it and start running those queries and dashboards against it. And that's great, and that's where most people are now. Where you want to go, and it's important to know the additional benefits you can have by building out a data warehouse, is you get to the predictive and transformative stage, where I can start to apply machine learning. So instead of being able to just look where I've been, I want to look where I'm going, and I can do things like predict when parts are going to fail, or have machine learning models that help upsell people. And so all those come with collecting that data and then running those machine learning models, training them on that data. And then you get to the transformative, where I view it as part of this digital transformation you hear people talking about. And that is to be able to collect data, no matter what the size, the speed, or the type. And so you want to build a solution that you're not going to go 3 months, 6 months, a year later, oh, well, we can't handle this data. We have a request for streaming data, and we can't support that in our system, in our solution in there. So spend a lot of time up front thinking of the use cases that you're going to need, hence all those questions, and you can make sure you can build something out that's going to last for quite a while. Okay, let's start with the modern data warehouse concept. And this is sometimes where I whiteboard it. For saving some time, I just put the result of a whiteboard. I always break it out into 5 stages. You want to ingest data, store it, transform, clean that data, model it, put it into a format that's more conducive for an end user to run queries and reports off that, which usually involves a relational database. And then you can have some visualization on that. And I put machine learning at that phase. Machine learning can come earlier. That little guy with, or guy or woman with the hat on there is a data scientist. And they may have the skill set to access data when it's sitting in a data lake. So one of the complexities about data lake also is it's a file and format. So it's just it could be essentially a bunch of CSV and Parquet files in there. So it could be difficult for end users to understand what all that means. But a power user, a data scientist, and especially the data scientists, sometimes want it in a file format. And so they're fine going against the data lake and not having to wait to get to the relational database. And when you look at this, some people may go, wow, this is extra work, extra ETL to copy the data along. It's extra cost. And it is, but the benefit is the data comes along and gets to a format that's very easy for self-service BI. So to explain that further, when we ingest the data, and I'm putting here Azure products, Azure Data Factory is usually that tool, we land it into a data lake in a raw format. And the data lake has a number of layers. And within each of these layers are file folders on there. So for raw, it may have file folders breaking out by source and then maybe by date. And then you need to clean that data. So once you do that, you put it into a clean layer, which could have its own file formats. Maybe it's by subject matter, like HR and finance. And then you could have another layer called presentation, where you maybe join some of that data together and make it to a point where people can start running queries and reports right off of that presentation layer. You could also have a sandbox layer where you copy the data, and maybe the data scientists want that. And this data lake design, I could spend a whole day just talking about that. So it's very important to have blueprints of what you want your data lake to look like, and you do that by understanding the source systems that you're going to pull from and how they would best fit in a data lake on there. And I see a lot of customers usually have at least 3 different layers in there. They may call them something different. I'm starting to see more layers in there called conform layers, because they may have data that's CSV and Parquet and JSON, and they conform it all into one format, usually Parquet, and they have that as a layer in there. And once you create these layers and you start copying data in there into the raw, and to get it to clean, well, now you have to have compute on top of that. So we use in Azure World, Azure Data Lake Storage Gen 2 to store the data. And to clean it, then we have a lot of options now. And this is where I'd say it can get confusing, and you have to really dive into the end users to find out what works best for them. Because you can use Azure Data Factory data flows, that's my abbreviation there, which is a very visual interface that once you create it behind the scenes, when you go to run it, it takes that data and puts it into a Spark cluster and runs it. So I always say it's a pretty interface over Spark. You can also use Databricks, especially if you have end users who are used to Spark to clean the data. And you can now use Synapse Serverless. You can use T-SQL over that data. So that can be a more cost-effective solution and helps out those who love T-SQL, which are many. And you can even use Synapse Spark on that. So I didn't list all of them here, but usually I see customers use a combination of them. I always say go at Azure Data Factory data flows because it's easy, and do it until you can't, until you come in a situation where maybe you need faster performance, or you need additional features that are not in Data Factory. Maybe you need to run some Spark library to convert data a special way or encrypt it a special way. And so you want to maybe for that use case go out into something like Databricks or Synapse Spark. And then in step 4 is you want to model the data in relational database, and you may move it into a third normal form in there. And that may be fine, especially if you're using Synapse with its MPP technologies. But you may then also want to copy it into a star schema. That's what SS is, because now you're getting faster performance when you query a star schema, and also you're defining all the relationships between the data. So the end user in step 5 in Power BI can easily drag and drop fields on a Power BI workspace in order to build the reports, because they don't need to know how all the data needs to be joined together. You did all that work for them. So to close out what I was saying before is, yeah, it costs more money and it takes more time to get it to this end format, which could be star schema, which could be in a Synapse dedicated pool, or it could be in a tabular model in Power BI. But you've made it much easier for the end user. And as opposed to just putting it in a data lake, you have to have a lot of extra skills to get the data in there. It could take longer to query things. You're just doing all the work up front, because somebody's got to do the work wherever it lands. If you're a data scientist going into data lake, you have to understand the data, and you have to write queries on top of that, and you have to create the metadata for it in that query or that view. IT can do all that work for other people. So think of all the trade-offs when you're looking at a modern data warehouse. Now, what this would look like in a prettier diagram, applying some more products on it, is like this. So each layer in here can have multiple tools. I even put on here, you can have like SQL database, SQL Server. That would be if you have a very small amount of data. You could start out with something like in SQL database, but be aware it's probably going to grow, and maybe you just don't want to have to convert later and just use something in Synapse, especially with Synapse having a serverless option that right now only goes against the data lake, but hopefully soon will go against a dedicated pool of relational database. So you can save a lot of costs by having that serverless and not have to go to the more drastic step of using something like SQL database to save costs. And these products span more one area in here, but I put in what they're mostly used for. And I'll also point out that with Power BI, you can use that for all of these steps on here. I view Power BI as a self-service ETL tool that is not for an enterprise solution, and it's not for IT to use, but rather for end users to maybe have a quick win. They can use Power BI to do all of this, all the cleaning in there, because it has its own data flows or Power Query in there. Or you can use Power BI to prototype. And this is what I think is going to get popular, is instead of IT going to an end user and saying, well, give me your requirements and I'll go and build something for you, they could just say, go and build it in Power BI. It's a pretty easy tool. I'll use that as requirements. And you can even take some of what they built and put it and copy it, the code, into a enterprise solution in there. But Power BI can be that way to prototype things and use for business requirements. All right, what's a data fabric? The modern data warehouse can be thought of as by adding additional features as a data fabric. So this is where I'm seeing some confusion. Some people are just calling the modern data warehouse a data fabric. And I'm seeing data fabric being used more often now, and maybe modern data warehouse term goes away. But I think of data fabric as an extension of a modern data warehouse where you're adding additional features to it. And you're doing things like master data management, MDM. You're having metadata catalogs with lineage on there. You're having data access policies on there. Maybe you're doing ABAC, attribute-based access control. Maybe you have data virtualization on there, and you do real-time processing, which you typically don't do in your typical modern data warehouse. You need real-time streaming in there. And it could be things like having data science tools and making all your data available through API calls, instead of having to connect to the data. And then lastly, you may build out your data fabric in building blocks. And you can call those building blocks products too. The idea being is maybe I have this data fabric and I have a data ingestion piece, and I have a storage piece and a master data management piece. And those could be used outside of data fabric. Somebody may come along and say, well, I can't use a data fabric, but you built this really good data ingestion piece. Can I use that? And if you built it where it's generic enough, you can have that code copied to that other group within your company, or maybe you create an instance of it and build it that way in there. But a data fabric could be built in a way that a lot of code reuse can happen outside of the data fabric. All right, let me take a coffee break so I don't lose my voice. So hopefully that level sets what a data fabric is. It's a glorified modern data warehouse. The other term you hear a lot about is a data lakehouse. What is that? If we look at the history of data warehousing, late 80s, that's kind of when I started, you just had a relational database in there. That was it. If you had a lot of data, you can use products with MPP, massive parallel processing technology like Teradata and Netezza. And eventually with Microsoft, it was the parallel data warehouse, which I first worked on when I came to Microsoft. Then in the late 2000s, only maybe 11, 12 years ago, came this idea of a data lake. And this was all on-prem at the time. And you could have this glorified file folder where you just dump everything in there. And some people went the route, well, we don't need a relational database anymore, we'll just put it in the data lake. And that failed spectacularly. I have some great examples of customers who came to me and tried to build a data lake and said, we don't need relational databases anymore, and it just didn't work out. So they learned from that and said, we'll have this cloud data platform that'll be a combination of a data lake and a data warehouse, as I've drawn out in this presentation. Now what you're hearing recently is the term data lakehouse. It's taking a data warehouse and a data lake and calling it a data lakehouse. And this is getting popularized by Databricks. The idea being, let's just go with the data lake, but we're going to learn from the mistakes of before by making the data lake more powerful. And the way we do that is by adding a Delta Lake on top of that. Think of a Delta Lake as an abstraction layer on top of a data lake. It's not storage in itself, it's just adding functionality to a data lake. And some of that functionality is things like ACID transactions, which you have in a relational database but don't have in a data lake. So gives you support for that. Time travel, where you can version files, which help for auditing, but also having to roll back. So I can go in there and I can query data and I can put a date in there as of, and it will give me the data from that time and ignore what's happened after that time. It's kind of neat. It makes it easy to do streaming with a Delta Lake. It can enforce schemas in there, which is very important, as opposed to an open world where people can just throw all sorts of files in a folder and the schema could be way off. Delta Lake can enforce it, so you're not having queries that are blowing up. It also has better performance, especially when it comes to updates and deletes compared to a data lake. So by putting all of these features on top of a data lake, you can have your data lake, at least in theory, have some of the features of a relational database, so you don't need a relational database. So those use cases for that, the reasons for that you can go with a Delta Lake and not a relational database is because of these four reasons, these four issues that you can solve. One of them being reliability. If you have a data lake and a data warehouse, you have to keep them consistent because you copy one data from the other. So you can have problems if ETL blows up. Now the data lake could have data that's different than the data warehouse. You also have staleness when you have both of those because maybe you only copy over once an hour. So the data lake could be newer compared to the data warehouse. If you're looking at analytics, and especially machine learning tools, they generally want to work with files. And so a data lake is better for them. And so you can have more possibilities when you're using machine learning tools on a data lake compared to a relational database. And then lastly, is total cost on there. I have 2 copies of data. It's going to cost me a lot more money than just having 1 copy of that. So these are the reasons why you could look at just going with a data lake and not a relational database. However, there are trade-offs, as everything in life. One is the speed. I touched on some of this before, but the idea is relational database, they have things like query plans and statistics that and indexing and a lot of things and features, especially when we get to MPP technology, that can just make it a lot faster than a data lake. Now, maybe your SLAs will say that's okay. If the queries take a few seconds, that's fine. I don't need the millisecond response, but there may be times when you just need that speed. So especially when you're doing slicing and dicing of dashboards and stuff. So keep that in mind, that performance will suffer. No security, security is not as good as I mentioned before. You don't have role security comm level, dynamic data masking. These things are not in a data lake or a Delta lake. Now, there are workarounds. You could add additional products into a data lake or Delta lake to get some of this, but now you're adding more cost, more complexity. You're having additional copies of data inside of the data lake to do all this. So if you're going to do all that, why not just go from a relational database on there? The complexity, what I find is if you have a data lake and you have all these layers and these folders, if you start copying a lot of sources into there, you can have hundreds of folders, and it just gets very complex. And it's very hard for people to navigate a world where it's just files. So they want the work done to put it in a relational database, because in that case, the metadata is combined with, it overlays the data on there to make it much easier to find data and explore it compared to a data lake, which has files which may have metadata inside the files, which makes it tougher to find out what those files are, or it may have a solution that keeps the metadata separate and other files in there, but you have to have a tool that knows that the metadata is separate, and there could be a disconnect that could happen at times on there. So it can just get so nearly impossible for people to manage and query a data lake when there's a lot of sources in there. And then in data lake, there's still missing features, even though you have Delta Lake on there, like things like reference integrity, workload management, certain encryption are just not into a relational database or into a data lake in there. And you're usually locked into Spark. So if you're using Delta Lake, it's Spark. So if you're a customer that doesn't want to deal with Spark, then you want to stay away from things like the Delta Lake. And then finally, people are used to a relational database. I had somebody point this out the other day, is that if have end users and they've been spending years using a relational database and now you're switching to this data lake or Delta Lake world, it could be a huge change for them, which may not be worth it. And it may be better to create a relational database. Now, this is where with Synapse, this is where I'm starting to see some exceptions to that. Because with Synapse, you can have T-SQL over the data in the data lake. And this was the big change because in the past with a data lake, if you're using a tool on top of that, it requires you to maybe use Hive SQL or Spark SQL. And that is a big change for some end users compared to T-SQL. Even though it's pretty close, some people don't like change. And if you say you have to learn a new language that's different than what they're used to, you may get a lot of pushback. What Synapse did, one of the great things it did was it makes it so you can use T-SQL over data in the data lake. And I can create a view that points to that file and has the metadata in there. So the select statement will have here are the fields. And once you create that, an end user can use that view, and to them, they think they're using a relational database. But the reality is, behind the scenes, it's data sitting in a data lake. So that opens up a whole new world where you can create views on top of the data in a data lake, and that is your metadata layer, and that can make it much easier for end users to use data in a data lake. So you've done some of the work, but not to the point of building on a relational database. So that solves the problem of making it the complexity. And then if you're using Power BI, that can solve the problem of speed and security, because with Power BI, you can ingest the data into Power BI and you can have a tabular model, you can use aggregation tables, and those will give you the millisecond response time, as well as in Power BI, you can have row-level security. So I'm starting to see customers now who are in the Microsoft world using Synapse and Power BI and getting away with not having a data lake or not having a relational database. And if you get to the point where you go, oh, well, actually, we do need a relational database, maybe we need faster speed, you can copy that data into a relational database, say the Synapse dedicated pool, and you can just use the same T-SQL, just point it now to that relational database on there. And as down the road with Synapse coming out with this next version, and it's going to have serverless, not only on the data lake, but into a relational database and multi-clusters. It's additional features that are going to make it even more popular to start putting solutions just in a data lake. So, which I never thought I'd say a few years ago, but now I can see the benefits with Synapse and the cost savings and the less complexity of using just a data lake in there. But I still think in the end, it's still going to have a large majority of customers are going to have both. All right, data mesh, which has been all the rage lately. So looking at that history that I showed you before, we're now adding one thing to it. All that history before was always centralizing the data. It was always copying it from all these source systems and locating it in one spot that IT controls and has ownership over, and IT cleans it. And where the data mesh is coming from is this decentralization approach. Instead of copying all the data into one location, we keep it in these various domains. And the way that works is if you have domains like HR and finance and payroll and operational data, those, you break it out by domains, and those domains have ownership of the data, and you're not copying it to a central location. So IT is not getting ownership, it's those domains are kept with the ownership. So that's the first point. It's a mind shift where the domains have the data, they clean the data, and they make it available to everyone else, and they stay as the owner. Now, IT will have a say in how the data is cleaned. So you want to have what's called data infrastructure as a platform. It could be, here's the way, a framework for what you should do to clean the data. So you can't have somebody saying, well, I'm going to clean the data and I'm going to use abbreviations for states, and somebody's going to use the full name. You have to have these standards that are created so everybody's cleaning data the same way. And you can also provide to them certain pipelines that they can reuse, templates, all these things to make it easier for them to manage the data. Because you're giving them more responsibility now, and therefore they're going to need more help. So this is where we now have cross-functional domain data teams. Instead of having all those people within IT, you essentially hire more people, and you hire those engineers to be within all the data and all those domains on there. There is less ETL because you're not having to copy all the data to the central location. So that's where we list the second point on here is the pipelines. Instead of the pipelines being this big concern, it's the domain data. And now we start thinking of as data as a product instead of data as a byproduct. So what you tend to do in a data mesh is you create these, IT will create these contracts that each domain has to abide by to make it easier for others to access their data. And therefore, they're treating it as a product by following that contract. And then you go from having a centralized data lake or data warehouse to all these data products that are separated out. And the use cases for data mesh, the problems that it solved are lack of ownership. Who owns the data if we're copying it to a central location? Is it IT or is it still the data source team? So now we make it clear it's the data source teams that own the data. Lack of quality meaning that instead of having IT clean the data, which it may not know very well, you're now having the data domains clean the data who know the data best. So it improves the quality of the data. It also improves scaling. Instead of IT being the bottleneck, everybody's going to copy it to a central location. If you want a new data source in there, you have to wait till IT has time to go and do that. Instead, you have all the domains who've hired people to do all that work, so you're able to scale. So if you have dozens or hundreds of domains, and each of them has their own team, they can go and clean all the data, do things to make it available, and not have to wait on IT. So IT is not the bottleneck. And then the last one being technical scaling, and that the current big data solutions are struggling with encapsulating all this data on there. They can't scale. So by having the data separated out and kept in the domains, as I add more domains, each of those domains get their own compute and storage. And you can scale up that way and not have to worry that by centralizing everything, those big data solutions can't keep up with that. That's the theory, that's the idea. And understand that data mesh is not a technical solution. If you read all the documentation on there, it's mainly an organizational change. It's a different way of thinking of things. There is no technology behind it. That's where one of the problems is something can sound great in theory, but is it viable to build this? And that's one of the concerns I have with the data mesh, as well with many other. So I'm gonna start bashing data mesh here. I will point out that I have seen some customers who could be good use cases for data mesh, and you just need to be aware of all these concerns. So if you go through those concerns and you go, hey, you know what, I'm aware of these, James, but I think it's still data mesh will work for us, then go for it. But don't jump into a data mesh and start building it without really going through all these concerns, because it's very likely it won't be for you. So some of the concerns, which I've listed here, I have more of them on my blog. I didn't even put all of them in there because I could go on forever as I'm talking to more and more customers who are building data meshes and finding some of the issues they're having. One of them is no standard definition for data mesh. I say if you talk to 10 people and ask them what a data mesh is, you'll get 15 different answers. So how can you build out something that nobody has a consensus of what it actually is? It's the other big thing is it's a huge investment in organizational change. So the first thing I ask companies is your organization open to massive change? Because now you're going into domains and you're saying you need to clean your data, you need to aggregate it, you need to do all these things instead of IT doing it. You may get a lot of pushback from that because now you're telling them you need to build your own teams. They may go, well, I don't want to do all that, and you're pushing this contract on me, and I'm just focused on building out my solution and satisfying my needs. Why should I make all these changes, do this extra work? Because saying it's for the greater good of the company may not work, and you have to have incentive for them. So this is where it can get really challenging, especially if you have dozens or hundreds of domains in there. And all it takes is one to say, I'm not doing it. Now you have some outlier. Now you have, how are you going to incorporate their data? Because at some point you need to collect it all together for a lot of reporting, which is the next problem. Is if we have all this data and it's all separate in their own data lakes or relational databases, now we need to combine it, then regardless of what you hear data virtualization companies say, is it's going to be a massive challenge performance-wise to combine all that data. And then where do you master the data? And so there are, within a data mesh, they have ideas of taking domains and aggregating them together, which I find interesting because it's kind of goes against the point of, I thought of a data mesh is to have everything separate. Now you're saying, well, we need to, for performance reasons, aggregate that data together because now you have additional ETL pipelines. So there's some things that are just kind of inconsistencies in the data mesh approach. And what I find a lot of customers have exceptions to what the theory is. And they may not centralize, they may not have the data separate in different data lakes. They may create one data lake and just have different folders. And that could be your solution for ownership. I'll have separate folders and I'll just say each of the domains owns those folders, but it's all located in one data lake in there. So there's a lot on here, and I don't want to spend the rest of the time just going through all these concerns, but just be aware of all these. And I would say the final one too that I see is, well, two things. One is it takes a long time to build data mesh. This is not a shortcut. This is going to take a lot longer to build in a modern data warehouse or data fabric. So you have to be aware of that. And the other is, if you're going to combine all this data, which you always are, and each of those domains are thinking just in terms of what helps them in their domain. They're not thinking of the bigger picture. So they may do things to help their situation, but it hurts the enterprise view of all this data. And so you have to do this extra work to pull this data together because they didn't put it in the format that's conducive to joining with other data. So these things all start coming out when you have everybody going, kind of doing their own thing. Yeah, they're following the contract, but they're still focused on solving their own needs and not the enterprise needs. So that was the benefit of copying all that data to one. You can have central IT looking at the bigger picture and then putting that data in a format that makes it easy for others to query who need views of all the data and not just one domain. However, if you do go with a data mesh, just these are the keys to keep in mind in there. Have pain points. Don't say, I'm just going to use the data mesh and everything's working pretty good now. Is what are your challenges now? If you have problems with ownership and scaling and these other things in there, then maybe you want to look at a data mesh. You have to be very open to change. That this is going to be by far the biggest problem, is organizations that are not open to that. And you have to have people that can influence change. in there. So that could be a lot of work. Just think of all the time and effort it could take to convince possibly hundreds of domains that they have to change the way they're doing things. Of course, you want to get experienced people, find somebody who's done this before, which is going to be a challenge because there's not many out there have built data meshes. The concerns I talked about, don't just say, well, this is a cool buzzword, it sounds great in theory, let's go and do it, without doing a lot of upfront work and research on a data mesh. The vendors have almost got to the point where they come out and say, we have data mesh in the box. So don't go by that. Understand data mesh more fully, realize it's not a technology thing, it's an organizational change. So I don't care how great your technology is, it's not going to help with this organizational change. And even virtualization software, which a lot of it is really good, but it has certain limits. You got to be aware of those limits if you're going to use virtualization software in a data mesh to say join those domains together, adding extra complexity, extra cost, and there are situations where the performance will still suffer. And don't go by the book, meaning this is the theory that was proposed, I have to go by that. There will be exceptions to it, as I mentioned, like centralizing the data, and have a long runway, because you could build something in a modern data warehouse that may take a year. If you go to the data mesh, it may take 2 or 3 years. So be aware that you need to have that extra time to go out to the data mesh. Well, what does Microsoft think of this? Since we're talking I'm talking in an Azure conference today. So Microsoft, and this is my view of Microsoft, having worked there, and then they have groups within Microsoft who are building data meshes for customers. And then outside of Microsoft, just seeing how people are going about building data meshes using Azure. You tend to find, as I touched before, the data infrastructure is centralized, and the storage is part of that, and that's all centralized on there. So it allows you to have the data in one spot, and then you'll have access controls, because that's the other thing, security. If you keep that data separate in those domains, you're now relying on them to do the proper security on that. So that makes me queasy, because all it takes is one not to do it, because IT is now out of control of that. And as much as you tell them this is the way you should be doing it, you may not have people that follow those rules. So if I centralize the data, I can also centralize the security. And if we look at this in solving in Azure, there's links now that Microsoft has where they first called it a harmonized mesh instead of a data mesh, and now they're calling it enterprise scale analytics. So you can go to these links and you can see Microsoft's view on how to build a data mesh or enterprise scale analytics with Azure. And it's really good. They have ARM templates and GitHub and the link there, and you can go by this blueprint or framework to build out a data mesh in there. And you can see from this diagram, you have all these nodes, those are domains. Each of those domains have their compute on top of that, but the storage there is a data lake that's centralized but broken out into folders. And therefore, and you can see that on the top right, therefore you can, again, it's not fitting the theory, but it can be much more performant, and you can have IT focus on the security, and it could be a better option than trying to do the data mesh complete theory on there. So have a look at this to see if this will fit into your needs if you're building a data mesh and you're in the Azure world. And usually I'm going to ask, well, okay, we have a data fabric and a data mesh. What are the differences? Especially if I have a data fabric and I say, I'm going to use data virtualization in there. So I can keep all the data separate in these different domains. And what I found is that usually with data virtualization, customers are not keeping all the data separate. They're just having a few pieces here and there that are virtualized, and they're mostly copying everything into a centralized location. It could be that they keep it separate and use virtualization because they need to keep data in the country, is the big example on there. So that's a part that's like data mesh like, but everything else is centralized. And if I'm using virtualization, it's still not where you're creating the data mesh full on way to go about it, where you have contracts with these domains. You're just still having IT have ownership and control of that data. They're just keeping it outside of central IT for security reasons and such. And usually you will still have that IT team, and you're not going out and saying, we're going to essentially reduce the IT staff and we have all the domains hire their own data engineering teams. That is not part of just the data virtualization in there. So it's not where I have data fabric and virtualization makes that a data mesh. Now, this is where we get confusion too, because I've seen Gartner say that a data fabric and data mesh are the same thing. And hopefully through this presentation, you see my view is that they are very two different things. And it's just sometimes a matter of people using different but using these buzzwords and have different definitions for them. And then I have this slide to try to help understand the differences between the two. And most customers are going to go through the data fabric solution in there, because the data fabric is going to focus on the consumption of all this data. And when we get to ontologies, it's the relationships of how all this data, creating relationships between all this data. So the other problem that data mesh struggles from is each domain is just concerned with their data, and they're not thinking about how this relates to other domains. With a data fabric, you can create a system, even a graph database that shows how all this data is related, these different domains on there. That's a lot easier to do if the data is centralized and you have one unified group looking at the data and defining those relationships on there. You also have, with a data mesh, multiple governance layers. You can recommend how they govern it, but all those domains are governing it. So you can have dozens of governance layers, which, as I mentioned before, with security can be a very scary thing, as opposed to IT collecting all the data and putting their own security on top of that. So that's the third point there. And then the consistency is, how do we apply that consistency across all of this? The issue I have, or another issue I have with the data mesh is as I mentioned, you can have the states. I define states as abbreviation or full name. So you have a lot of that inconsistency that can happen with the way they go and they govern the data on there. And they can do it very differently than all the other domains. Think of languages. Each domain can say, I'm going to use my own language in there. Okay, great. Now, how are you going to join all that data together if all this data is in different languages? If you have a data fabric, you copy it all to one, you decide what that unified language, what one language is going to be, and you pull it all in there. So you don't have all this extra complexity of trying to join the data together. And then maybe the biggest point is in implementation, it is extremely complex for a data mesh to build. And you can go out there and you can see there are use cases and videos of people who build out the data mesh, but nobody goes, oh yeah, we built a data mesh in a couple of months. It's usually, we've been building a data mesh for 2 years now, and we just got it put in production in there. So it's a lot simpler with data fabric, especially if you have data virtualization tool. You can make it easier to keep data separate and pull it in on there. And you can have things like a metadata catalog. You can create, it's a lot easier to create things like master data management, which is the other big thing in data mesh is if you have all these domains and they're all having customer data, and now you say, I need to combine that data, and you can have duplicate customers. Well, where's the mastering of that data done? I have to, that's the whole point of master data management. You have to combine all that data to find the golden records. If it's all kept separate, how do you solve that? And the solution that data fabric, the data mesh people talk about is, to me, not good for MDM. So that's another big concern you have to have. So in the end, you have to think through all these concerns, and maybe you'll be okay with all those concerns and you'll go to data mesh route. But I think most people are going to go the other way of a data fabric. So it's going to be interesting to see in the next few years how popular data mesh becomes. And the concepts in data mesh are not new. They've been around for a long time, and they're just given a new name. And it's still, there's good work in understanding whether you use data mesh or data fabric. When people are talking about the data mesh, they are seeing the value of data. They're seeing, however you want to do it, where you can make better business decisions with data, where you can build machine learning models, and in the end, make those better business decisions. And so you can see the true value of data. And that's the whole point of whatever technology you choose. Is in the end, you're going to have people who are going to be able to query that data and report out that data and see insights to things that they never knew before, and therefore make those better business decisions. All right, that is it. I want to thank everyone for attending. If you have further questions, I don't know if we'll ask any here, but I'm happy to have emails, questions to me. I expect I'll have some. Don't be afraid to shoot out an email with a follow-up. And then, as I mentioned on my blog, I talk about these topics too, and there's a lot of Q&A at the end of some of those blogs that you may want to look at to help you understand all these different terminologies. So thanks, everyone.
Thanks a lot, James. And as you really said, considering the timeline also, I'll consolidate all the questions and I'll post it over email. And
Sure.
okay, sure. Thanks, James. We have Annie. Hi, Annie.